Given a line L, Safia, you will also be able to answer all the question. Okay, you just think about it, you will be able to answer. So I'm writing the question, think about it. And a point, there is nothing new in this chapter, Euclid's geometry. Whatever you have learned so far in mathematics, everything just in a combined way is there in this chapter. Okay, you got 13 triangle. Okay. Okay, Tejas. Yeah, great. Keep working and keep it, maintain it like this. And a point P on it. How many lines can be drawn passing through the point P? Options are there: infinite, 1, 2, and all. Infinite, option B1, option C2, and option D3. Okay, I think Tejas, you have messaged already. And I got 30 marks in triangle and lines and angles too. Great. Okay. Yes, I can see you, the improvement. You are having exam in October. And yes,
In
this
September.
way in September only. Okay.
Yes.
Then you are on the right track, Tejas. Just keep moving. Okay. And keep practicing. So yes, this is the question we are having. Please tell me what will be the correct option. Think about it. Meanwhile, let me check what will be the next question. Okay. Infinite. Tejas has responded infinite. Farhan, yes.
I have not given the answer yet.
Okay, Irshad. Irshad has given the answer. Okay, continuously you are messaging. That's why I thought. Okay. Irshad said infinite. Safia said infinite. Yes. Rest of the students. Sarah. Farhan, please wait at last. Okay. When like
Okay, ma'am.
towards the last of the class, when everyone will leave, just you don't leave. Wait. Okay. Okay, let's discuss it. Okay, what does the statement says? Given a line L, okay, and a point P on it, How many line can be drawn passing through P? How many line can be drawn passing through P? Let's see how many line can be drawn. From P, we can draw a line. Okay, from P, we can draw a line. From P, we can draw a line. Okay, from P, we can draw a line. From P, we can draw the line. Okay, so how many line we can draw? There are so many line which can be drawn through P, and that is infinite. You don't need to learn like the concepts from Euclid geometry, and then only you will be able to answer. This is very basic question. Okay, and these concepts are there, Safia and Euclid's geometry. Okay. Let me give the next question. If a straight line, it's a straight line, okay? I'm trying to write a straight line. Straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles. Then the two straight line if produce indefinitely meet on the same side. Wait, on which the sum of angle is less than options are right angle, two acute angle, two obtuse angle, and two right angle. Read the question carefully, then I'm scrolling down to check the options.
I have given that.
Two right angle. Okay, we'll check it, Tejas. Yes, rest of the student, what
Okay.
are you thinking? If a straight line falling on two straight line makes interior angle on the same side of it taken together less than two right angle, then the two straight line if produced indefinitely meet on that side on which the sum of angle is less than. Yes, Irshad, Sarah, Farhan, at least you have done this chapter properly. Okay. Yes, Sarah and Farhan, what are you thinking? What will be the correct option? Let me explain it. It says that if a straight line, okay, listen to me carefully. If a straight line falling on two straight line, okay, if a straight line falling on two straight line, okay, a straight line P is falling on two straight line L and M, okay. Now, if a straight line falling on two straight line makes the interior angle on the same side of it, makes the interior angle on the same side of it, that means it's talking about this two angle, or maybe this two angle, that's called interior angle on the same side, right? Okay. So if a straight line falling on two straight lines makes the interior angle on the same side of it, taken together, that means added together. Okay, taken together means added together. Okay, this two interior angles, suppose this is x, this is y, we are not saying it's same. Okay, interior angle taken together, it says taken together, it says just that. Okay, or maybe other one, if you are taking the interior angle on the same side, taken together, if this is z, this is k, then taken together means added together. Okay, let's combine from the very beginning. If a straight line, a random straight line we are having, which is falling on two other straight line, makes the interior angle on the same side. Okay, the straight line which is falling, making the interior angle on the same side, taken together, is less than two right angle. If it is less than two right angle means 2 into 90. Two right angle means 90 plus 90, or maybe 2 into 90. Okay, it is less than two right angle. Okay, that means less than 180 degree. Basically it want to say less than 180 degree, but just has twisted the statement and says less than two right angle, or maybe that z plus k, if that is less than 180 degree. 180, it doesn't say 180, it says that two right angle, that means 2 into 90. Okay, which is basically 180. If that is less than two right angle, okay, if that is less than two right angle, then what? Then the two straight line, if produce indefinitely, if we will produce it indefinitely, okay, meet on that side, it will meet with each other, on which the sum of the angle is less than two right angle. Correct option will be the sum of the angle is less than two right angle. It will meet. So basically, we are having a postulate which says that if you are having two line and there is a line falling on it, then interior angle on the same side taken together, that means added together. If that is smaller than 180 degree, if it's smaller than 180 degree, then if you will produce it, if you will extend it, you will find that both are going to meet with each other. That's what the statement, this postulate we are having, given by Euclid. And everything in this postulate is
Postulate.
given in the, yes, postulate 5. Everything in this postulate is given in the statement form, just the last part is missing. So we understand this postulate means if a straight line falling on two straight line, interior angle on the same side taken together is less than two right angle. Okay, then the line, if produced indefinitely, then if you are producing it indefinitely on the side where you have got interior angle less than 180, on that side only you are producing it, then it will meet with each other. Okay, so you can connect this concept with the lines and angles chapter. One concept was there, if two parallel line you are having and there is a transversal, then interior angle on the same side sum is 180 degree, right? Yes or no? Yes, Safia, yes or no? Are you there?
Yes, ma'am.
Do you know this? That if we are having a parallel line, like L is parallel to M, and if there is a transversal, then we can say that x plus y must be is equals to 180. Can we say that? Co-interior angle or maybe interior angle on the same side? Safia.
Yes, ma'am.
Here, just the upgraded version of this one is, if this is not 180, if this x plus y is not 180, if it is smaller than 180, then the lines are not parallel. It will meet with each other. That's what the statement says. Think about it. If we are having two random lines, parallel or not parallel, we don't know. L and M are parallel or not, we don't know. Okay. There is a transversal over here, that is P. Interior angle on the same side taken together. If the sum is smaller than 180, then it will meet with each other, produce indefinitely, and it is going to meet. That means if it is 180, then the lines are parallel. If it is smaller than 180, that means the lines are going to meet with each other. Got it?
Yes, ma'am.
Yes, ma'am.
Okay. So that's what this Euclid, I have taken proper time to explain this statement in our class, but here again I have explained it. Okay, from the basics I have explained this statement. So yeah, let me give the next question. The word geometry comes from the Greek. Yes, anyone trying to say anything? Which means options are there. Okay, option A is geography and meter. Option B is globe and meter. This is you. Option C, go and to measure. Earth and to measure. Yes. Which one is the correct option?
Ma'am, geo and measure. Earth to measure, sorry. Earth to measure.
Yes. Yes. Okay. Basically, it is the geographical reason and that to measure. We can call it earth and to measure. Okay, geography. This geometry word came from geo and metry. Okay, started with this concept came for measuring the like geographical region and all, and then later on we just had a expanded version of like in mathematics there is a part called symmetry, there is a part called trigonometry, so it became huge later on, but initially it just came for measuring the geographical region and all. So basically it came from geo and meter. Geo means geographical region which can taken as a earth, and measure material means to measure it. Okay, everyone getting it?
Yes, ma'am.
Now the next one, the three step from solid to point are solid surface, lines, points. Okay, solid, lines, surface, and points. Line, point, line, point, surface, solid. And the next one is lines, surface, point, solid. Yes, which one will be the
Ma'am,
correct option?
C.
C,
And 3.
3. Line, then point, then surface, then solid. Okay, we will check it. Yes, anyone else? Irshad, Safia, if you can think. Sara, Farhan. Which one is the correct option? Think about it and let me know. Okay, let's discuss. Okay, in our actual class, I have explained it very well. If you can recall, okay, that we are having just points combined together and has given us a line. Points combined together just got attached with each other and we ended up getting a line. Now lines combined together has given us a surface, and surfaces combined together has given us a solid shape. Okay, so and the
Yes,
example
ma'am.
also I have given. Example also that like this point is having 0 dimension, no measurement is there. Line is having 1 dimension, only length we can measure, nothing else. Surface means rectangular surface, square surface, or whatever. Surface is having 2 dimension, length and breadth we can measure. And solid is having 3 dimension. Okay, and the example also I have given in our actual class, that you must have seen that this cotton thread comes from the cotton seeds. So seeds has taken the shape of thread. Okay, seeds taken the shape of thread. Then thread will take the shape of a piece of cloth. Okay, just a sheet of cloth. And the sheet of cloth will take in the shape of maybe shirt, maybe trouser, maybe cap. These are just the 3D figure. Okay, a cap like this. Okay, so this one is the example that how The point got converted into line, line got converted into 2D surface, a circular plate or triangular plate, or maybe rectangular or a square sheet, whatever you want, you say, or that will get converted. So many seats when you will take, you will be giving it a shape of box. Okay, you will be able to give it a shape of cylinder. Okay, or maybe cone like this. So from solid to point, see, solid, if we have to go back, then see carefully. Solid to surface, surface to line, line to point. Okay, solid to surface, solid to surface, surface to line, line to point. Can you see it? Just check it from the last. Point got converted into line, line got converted into surface, surface got converted into solid. Are you getting it?
Yes, ma'am.
Yes, rest of the student, are you getting it?
Mom.
Okay,
Yes,
so
Yes,
these
ma'am.
these points also, as I was telling you, Safia, that this chapter is more about theory. Okay, when we were discussing this chapter, it felt like we are discussing a history chapter. Okay, where I am just telling you the stories. So yeah, these are the concept which we were discussing in this chapter, Euclid's geometry, given by the Euclid, that how point to solid we are getting. Next, now I feel like, Safia, that once we'll be doing few more question, and you will understand all the concepts from here. And when the actual class you will be taking from this Euclid geometry anytime, you will be able to recall everything, whatever we are doing in our revision class, where I am just giving the questions, nothing else. Now, the next question is boundaries of solids are. Option A, surfaces. Option B, curves. Option C, lines. And option D, points. Yes, Tejas. Tejas. Which one is the correct option? Tejas, can you hear me? Okay, anyone else? Yes, Safia, Sara, Farhan, Irshad.
Yes, ma'am.
Yes, Irshad. Which one is the correct option? Lines. Okay, the first one is lines. Safia has responded lines. Tejas, the answer is surfaces and the curves. Okay, let's discuss it. Okay, just a second. So boundary of solid. Solid means 3D figure. Now only we understood that solid means 3D figure. Okay, this 3D figure. These are solids. Or maybe this one is solid. Or maybe in mathematics, solid means not solid, liquid, gas. Okay. In mathematics, we call 3D figure as a solid. Okay. Solids means 3D figure. So boundary of 3D figure. It's a surfaces, right? It's a surfaces.
First, you have given boundaries of solids are. Second, boundaries of solids are.
Oh, wait, I wanted to check. Just a moment, no? I wanted to write surfaces and then by mistake I ended up writing surfaces. So boundary of solids are, can we say surfaces? Right? Think about it. If you will take a page, you will take another page, you'll take another page, and you'll take another page, you'll be able to make a box out of that. Yes or no? So boundary is what? Surfaces. Shall I show it to you? Let me show it to you. Can you see it? This is a solid figure. Okay, this is a solid figure. If you can see on the screen, yeah, this is a solid figure. Okay, boundary. These are the boundary. This is the boundary. This is the boundary. This is the boundary. This is the boundary, right? Boundary of solid figure is what?
Yes, ma'am.
It's a surface. It's made up of
Yes.
surfaces, right?
Yes.
Everyone getting it?
Yes.
Yes, ma'am.
Okay. Now I will show you a surface. A surface like this. A surface like this. And I will say boundary of surface. Boundary of this surface. This complete is a surface. Okay. It's a surface. Now boundary of this surface. Can you see it's a line? Can you see?
Yes, ma'am. Yes.
Getting it?
Yes.
So boundary of solid. Solid कैसे बना है? सॉलिड तो सरफेसेस से मिलके बना है तो बाउंड्री ऑफ सॉलिड सरफेस ओके सरफेस कैसे बना है सरफेस तो लाइन से मिलके बना है तो बाउंड्री या फिर कैसे बना है लाइक हाउ वी आर गेटिंग द सरफेसेस और मे बी व्हाट like shape we are having at the boundary it's lines right surface is made up of lines and the boundary is line only nothing else getting it now the next yes one is surfaces and the next one is lines now please answer how many line can be drawn through two given point if you are having one point and another point okay through this two given point listen to me carefully I'm not writing on the screen I'm just dictating it through two given point how many lines can be drawn through two given point
Infinite.
through two given point through two given point how many line we can draw yes this one everyone can think through two given point. One of the point is like this, another point is like this. See, Farhan, Sarah, Safia, you have not done. But Farhan, Sarah, and Irshad, what happened to you? Why you are not answering? Yes. See, sometime no, what happens that our team just okay. Tejas, you have responded. Yes, Irshad. How many line we can draw through two given point through the point A and B? How many line can be drawn?
Ma'am, only one.
Only one. So why you were not answering, Irshad? Sarah, are
Ma'am,
you
from
there?
two or one
Yes,
point?
ma'am.
How many line we can draw from? Yes, two. Tejas, two. Yes, Sarah, how many line we can draw through this two given point?
One.
Yes, just one. Okay. One and only one line we can draw. Only one. If you want to draw more line, like one of them we have drawn. If you want to draw more, joining A and B only, no, it will not be possible. You can join A and B, but that will not be a straight line. Okay, it's not a straight line. It's not at all a straight line. So only one line. Line means we want to check how many straight lines can be drawn. And one and only one straight line we can draw. Right?
Yes, ma'am.
Yes, ma'am.
Now the next. Just a moment. It is known that x plus y is equals to 7 and x equals to z. Then show that
Ma'am, this the same chapter?
yes. Okay, we have to prove it. Show means we have to prove that it's z plus y is equals to 7 by using Euclid axiom. It's very simple, Safia, if you will see this question. It's very simple. X plus y is 7 and x and z are same. Then prove that z plus y is 7. Which is very, very logical. Like, yeah, z plus y is
Ma'am,
7 only, but we have to write axiom over here. That is the main confusion. Okay, rest of the student, please do it and tell me which axiom we can use to prove it. Think about it and let me know.
okay,
Okay, let's
seven. Second axis.
second. Why,
Yes.
Tejas?
Ma'am, if
What?
equals are added to equals, the whole side.
Okay, second axiom if we'll be using, then what shall I write at first? What will be the um in our proof? What will be the first step? Tejas.
X plus y is equal to 7 given.
Then
And then x is equal to z given.
then
And
See, we can take at first, yeah, the given part we can write. After that, in the proof part, what will be the first? So you can write, since we know x equals to z. Okay, now adding y both side. He said it correctly. That second axiom we